Hello all, my name is Krish Nayak and welcome to my YouTube channel. So guys, if you have been following my LangChain playlist, my LangGraph playlist, I've uploaded tons and tons of videos. I have made end-to-end projects. I have taught each and everything specifically on this particular frameworks. Now, this particular video is just like a one-shot video on LangChain itself because recently LangChain has come up with its recent version, that is version V1, and there are some various changes specifically in terms of creating agents, applying memories. There is a new concept that have recently been come that is called as middleware. So considering all these things, I thought why not make a one-shot video with all the recent updates, and you can watch this entire tutorial. It will be a longer tutorial where I have included each and everything. So go ahead, enjoy this, and make sure to hit like. We'll keep a light target of 1,000 so that after completing this particular video, I'm also parallelly recording the updates with respect to LangGraph. And there is one more new topic that is coming, which is called as deep agents. So everything will be getting recorded as we go ahead. So go ahead, enjoy this particular crash course on LangChain version V1. Hello guys. So recently, LangChain has come up with a lot of updates in their specific documentation in the recent version. And in this entire series of videos and in this module, we are going to see the various changes which LangChain has specifically come up with, So here inside the documentation, if I just go ahead and click on docs, okay, so here you'll be able to see there is LangChain, LangGraph, and Deep Python. So we will be covering all these things, all these modules again in an updated way so that we are always up to date with LangChain documentation. So first of all, we will go ahead with LangChain documentation over here. Now here with respect to this particular documentation, there are a lot of changes specifically with respect to syntaxes, with respect to creating agents, how to integrate with multiple different models, how to go ahead and call a tool, how to come up with a structured output. Along with that, it also has support of messages, different types of messages like AI message, human message, tool message. Along with that, we'll also be seeing something called a short-term memory. We'll be seeing how to perform streaming, and there is a new concept that has basically come up with respect to middleware, like built-in middlewares, custom middleware, and we'll also be learning about guardrails and many more things. So in this entire series of video, we are first of all going to cover the entire LangChain recent framework, whatever the updates are there. And and we are also going to use an amazing package which is called as UV package manager. Now everybody, if you have heard about UV package manager, this is an extremely fast Python package and project manager, and it is completely written in Rust. So I'll give you an idea how you can actually go ahead and work with UV package manager, and this is the entire installation. How to probably go ahead step by step. I'll be showing you how you can go ahead and create an environment. And along with this, you can use any ID, right? There are also various IDs that are now available. We have VS Code, we have Cursor, we also have Google Anti-Gravity. Nowadays, I'm actually specifically using Google Anti-Gravity also. So all these things we will try to cover, and our main aim is always to stay up to date with respect to anything that is basically coming in LangChain. Okay. So from as we go ahead now, we will be covering this step by step, and I will show you how step by step how to go ahead and create an environment. And we will just start with a specific new project itself. So here you'll be able to see that I've already opened Google Anti-Gravity, which I will show you in front of you, right? And I've created a folder which is called as LangChain Updated. Now we'll start from basics. Now Google Anti-Gravity also, you can go ahead and download it. In order to download, all you have to do is that just go ahead and search for Google Anti-Gravity. Okay. And then this ID, this is like a agentic ID, like how we have VS Code, how we have Cursor, right? You can also download for Windows. This will be just be like a exe file, and then once you go ahead and install this, you will be able to start working on it. So this is the ID that we are going to specifically work on. The best part about this ID is like Cursor, it provides access to agent, and it also provides you completely for free. I think for some number of requests, not for infinity requests, right? But yes, with the help of agents, you will be able to write the code in a much more efficient way, right? So now as we go ahead, we will be covering the recent updated LangChain version. and we'll try to see that how we can go ahead and create agents, how we can go ahead and work with tools, each and everything. So let's go ahead and start that. So guys, now let's go ahead and start with, first of all, creating a virtual environment. And it is always a good practice that we start with creating a virtual environment, and for any kind of projects that we work with. So the first thing is that we will try to create a virtual environment with the help of UV, okay, UV package manager. But before we go ahead, we need to install the UV package manager, right? So how to go ahead and install it? So if you just go ahead and search for UV package manager, so this is the first link that you will be able to see it. Okay. So once you click it here, you'll be able to see in the installation, you have options for Mac OS, Linux, and you also have options for Windows, right? So out of both of these options, you can go ahead and do it. So let's say that if you're using Mac OS or Linux, you can use this command. Uh, if you are using Windows, you can directly open a PowerShell and you can execute this command, right? So how to open a PowerShell? So first of all, what I will do, I'll copy this particular command, and now I will go to my, the ID, and here I will open my terminal. The opening of the terminal is similar like VS Code if you're using VS Code till now, okay? Now here inside this PowerShell, see, you have PowerShell option, you have command prompt option. So here inside this PowerShell only, you can just go ahead and paste this command and just press enter. So once you press enter, the UV package manager, will get automatically installed. Okay. So I've already done that installation, so I don't have to do it again. But just to show it to you, I have actually done it. Okay. Now I will remove this. I will open my command prompt. Okay, or whatever, like let's say that you're using Mac OS, whether you're using Linux, it is up to you. Whatever things you really want to use, you can go ahead and use it. Okay, so till then I will just go ahead and close this. Now here the first step is that how do I go ahead and create my virtual environment with the help of UV package manager. So first of all, what I will do, I will initialize this entire folder as a working repository. Now, in order to initialize it, we will go ahead and use one command, which is called as UV init. Okay. So please make sure to remember this command. So if you want to go ahead and just initialize a working repository, let's say this is my working repository. So first of all, I will initialize it with the help of UV. So for that, I will just go ahead and write UV init command. Once I execute this, so here you can see it has initialized the project, which is called as Langchain updated. So as soon as you initialize the working repository, here you get some of the basic information, right? So here you will see pyproject.2ml. This will give the information like which versions we are specifically working with. So here we are working with Python 3.13. So recent updated Python package manager. Later on, like let's say if Python package is also getting updated, again, when you write UV in it, it will just take the recent Python version. Okay. And it is always a good practice to work with the recent version. That's the reason you can actually go ahead and directly use this. Now, along with that, you'll be seeing that a default main.py is basically there. Then you also have something called as Python version file. So here you can see that I'm getting 3.13. Okay. So all this information you can see over here in a very simple way. Now, the next thing what I will do is that I will just go ahead and write UV VENV. Now see, as soon as I write UV VENV and I put a slash, okay. Now what this will do is that it will go ahead and create a virtual environment. So once let me press enter. So here you can see that unrecognized subcommand VENV slash. So by mistake, I've put this slash. I should not have put that. So what I will do, I will just write UV VENV. Now in order to create a virtual environment, this is the most simplest command, right? UV VENV. As soon as I write UV VENV and I press enter, so here you can see that now it is using this Python 3.13.2 and it has created a virtual environment at this specific location .venv. So .venv is my virtual environment, right? Now in order to activate it, see, if as soon as you create a virtual environment, you need to install the libraries inside that virtual environment, right? Now, in order to install the specific libraries inside that virtual environment, I will first of all activate that virtual environment. Now, in order to activate it, the command is given over here. See, It is written activate with .venv script slash activate. So if you go inside the script, there is something called as activate. I just need to go ahead and call this particular or execute this particular command. So what I will do, I will copy this over here. I will paste it over here and I will just execute it. Now, as soon as I do that, here you can see that my virtual environment, right, is activated, which is called nothing but Langchain updated. So this virtual environment has got updated. Okay. Now the next step is that how do I go ahead and start the installation of all the libraries? Okay. Now installation of the libraries is very important. Till now, whenever we install a virtual libraries, you also need to make sure to keep an updated track of which version we are installing, right? But now with the help of UV package manager, this is becoming very, very easy now. Okay. So let's say that I go ahead and first of all create a requirement.txt file. And please make sure to create that particular file outside .venv folder. So I will go ahead and write requirement.txt. Now inside this, I will be using some of the libraries. Let's say one of the libraries that I'm using is Langchain. Then I have Langchain community. Okay. Langchain community, because I will be requiring this. Okay. Then I also have Langchain -OpenAI because I want to use this Langchain OpenAI. I also have to use Langchain Grok because I may also use Grok models. Then I also have Python -.env, right? So I will also be using this. Along with this, I will also use Langchain /Google GenAI. My main aim over here is to install all these libraries is very simple because I want to show you all the examples with different libraries and all. Okay. So these are my default libraries. And here you can see that it is also giving you some suggestions, but don't go through that suggestion. Go ahead and type each and everything in front of you. Okay. Now the time comes is that I have to go ahead and install all these particular libraries inside my virtual environment. Now here the best thing is that, see, I'm not given any specific version. We are going to work with the recent version of all these Langchain libraries over here. Now, what is the recent version? That also we will go ahead and check it out. So here what I will do, I will write UV add -r requirements.txt, right? So this is how you go ahead and do the installation. See, you can also go ahead and write UV pip install -r requirement.txt. You used to install all the requirement.txt by writing pip install -r requirement.txt. But with the help of UV, you can just go ahead and write UV add -r requirement.txt. Now, once I execute this, so here you can see that all my installation will start happening. Okay. It will give you some warnings, but it's okay. We can skip this warnings. Now here you can see by default, all the libraries has got installed. Now here you can also see all the version of the specific libraries that has got installed. Now, just by seeing this, you'll not be able to identify it. So what I will do, I will go ahead and open this pyproject.2ml. Now inside this, you will be seeing that, okay, Langchain 1.1.0 has been installed and this is the recent version. Langchain community 0.4.1 is installed. Langchain Google GenAI 3.2.0 is installed and all the different libraries has been installed. Now, because of this, you will be at least able to identify it because I will also pass you this pyproject.2ml file to just get you understand that, okay, right now we are in this specific versions. Tomorrow, any number of updates that specifically comes, you don't have to actually worry about it. At least you know which is the base version, right? But my suggestion will be always that try to work with the recent version of Langchain because there are many functionalities that will get deprecated. Some of the functionalities may get moved to some other libraries and many more things. Now, this is where we have actually got ahead and installed all our libraries. Okay. Now the next thing is that I will also go ahead and create some keys. Okay. So I will be requiring 3 keys. One is the Google API key. So I will go ahead and write Google API key. Okay. So I will go to Google AI Studio API key. And here you can see this is my dashboard. And there is an option which says create an API key. So I will go ahead and select one of the project. So let's say this is my project and I'll say, okay, this is my set key that I really want to go ahead and create, or I'll go ahead and name it as Langchain updated and I will just go ahead and create the key. Okay. Now You know how to create a keys, right? At least that I think you should be familiar with. I will go ahead and copy the API key. Similarly, I will go ahead with grok API key. So I will write grok API key, and here is my API keys. Okay. And I will just go ahead and click on create API key, and I can go ahead and create it, right? Similarly with respect to OpenAI API. So I have created all these keys, and what I will do, I will quickly go ahead and create one file which is called as .env, and I will go ahead and paste this API keys over here, right? So these are my API keys that I will be specifically using for my project. There is also one more library that I want to install for my Jupyter notebook. That is nothing but uv add ipykernel. Okay, ipykernel. So ipykernel, you will be able to see that that is also installed. Ipykernel is just like a kernel provided to the Jupyter notebook. Again, let me repeat it, guys. Whenever you want to add any independent libraries, you use this command, which is called as uv add. Okay, and then you give the library name. Okay, library name. If you want to directly install it from the requirement.txt, then you can just go ahead and write uv add -r requirement.txt. Okay, like it's just like you are doing the installation from requirement.txt. So in this video, what we have actually done is that in this section, we have created a virtual environment. We have created a requirement.txt file which has all the recent libraries, and we have installed it by using this command uv add -r requirement.txt. Otherwise, you can also go ahead and individually you can go ahead and install all the libraries by writing uv add the library name, whatever library name that you want. Let's say you want to go ahead and install Langchain. So here you can just go ahead and see that, and here I have already installed it, so it is showing me result this and that, right? Now, in the next step, what we are going to do is that we will start working on our LangChain updated documentation, and we will start implementing agents. We'll show you how you can go ahead and integrate different kind of models. So let's go ahead and start with that. So guys, now we have created a virtual environment. We have done the installation of all the libraries that we require in our virtual environment with the help of UV Package Manager. You can also see all those things updated in pyproject.toml file. And here you can see all these libraries we are going to specifically use it. Okay. Now you can also add your any descriptions that you specifically want to add also. Now what we are going to do is that we will start with the updated LangChain folder. Okay, so I've created a folder over here. So let me first of all delete this and create a new folder. So I will write updated LangChain. Okay, and I will start with the first file, which is called as LangChain intro.ipynb file. Okay, so let me minimize this. I will go ahead and select the kernel. I want Python environment.venv. Okay, and we'll write a markdown saying that this is the LangChain version v1. Okay, I will just go ahead and write it, and I will just go ahead and execute it. Perfect. Now, just to check everything is working fine or not, so I will also go ahead and open my code and I'll execute something. Okay, so this is working. The Python code is also working. Like 1 + 1 is a kind of a numerical operation. Now, my .env file has also been loaded. Everything is ready. So first of all, as usual, we'll go ahead and import OS. Then from .env, we are going to import load_.env, and we will go ahead and initialize load_.env, and we will initialize our OpenAI API key. So I will write os.environment, and here you can see that I will go ahead and write OpenAI_API key. So one thing about Google Anti-Gravity is that it provides you a lot of suggestion. Okay, so you will be seeing, okay, quickly when you're coding it, you'll quickly see all the suggestions that is coming up, right? So os.getEnv and OpenAI API key. So I will go ahead and execute this. So perfect. Now the first thing that I'm just going to start, okay, that is all about agents. Okay, now first of all, you need to understand what exactly is agents. So what I will do, I will just open my file over here. I will create a new file so that I write something to you so that you get an understanding. Okay. See, before, when we started working, right, when initially we got generative AI, at that time, generative AI is becoming very, very much as an important topic. But nowadays, everybody is specifically talking about agents. Okay. So everybody is talking about agents, and agents is altogether a very, very handy topic. Okay. Very, very important and handy topic altogether. So initially, if you go ahead and see, initially we were just talking about LLM models. So let's say that this is one of my LLM model. Now the LLM model can be anything. It can be an OpenAI LLM model. It can be a generative AI LLM model. It can be, Grok LLM model, any open source LLM models. The main task of the LLM model was that whenever we give any kind of input, right? Input. Let's say if I go ahead and ask, hey, write me a paragraph about artificial intelligence. So LLM will take that particular input and then it will give you a specific output. Okay. It'll give you a specific output. Like, okay, if I'm asking, write a paragraph, 200 words paragraph on artificial intelligence, it'll give me a 200 words paragraph as an output. Okay. This was a simple generative AI application. Okay. I used to say this as a Gen AI application. So Gen AI application. Okay. Application. Perfect. But now, as we move ahead, so let's say that for this particular LLM model, if I ask a question, hey, provide me with the current AI news or today's current AI news. So let's say that I want to know the today's AI news. AI news. Okay. Now, in this particular scenario, you know that LLM has a cutoff training date. Okay. So we basically say that LLM is already trained from previous data. It does not have the current information, right? Recent information, like let's say tomorrow's or today's information, it does not have, right? So LLM has to be dependent on some third party tool. Why it should be dependent on third party tool? Because when I'm asking this specific question, or tell me about the today's AI news, LLM does not have that particular information, right? Because it is already trained with the previous data. It is not trained with today's data. And there is always a cutoff training date, right? This is really, really important for you all to understand. So this is one of the problem of just using a plain LLM. Now, that's the reason whenever we say that if we need to answer, if my LLM needs to answer this particular question, it needs to be dependent on some third party tool, some tool. Okay. Whenever we say some tool, it can be a third party tool, it can be any kind of tool. Okay. It can be a third party APIs, it can be Google search, it can be something else, right? And based on this particular tool, what should happen is that whenever we give an input saying that today's AI, what are the today's AI news, the LLM should be able to make a decision. Okay, I will not be able to answer this particular question. So now I am dependent on some other tool which will be able to answer this particular question, because this tool is currently connected to the current data or current, like today's news, it is basically connected to, right? Specifically AI news. And this will be able to give me the response. And this response that you basically get from here, it is basically called as context, right? And then only the LLM will be able to generate the output, right? So in this particular scenario where we have a LLM being dependent on some other tool, and from where we are basically getting a context, as soon as we give an input, the LLM is able to make a decision. Okay, I'm not able to answer this. I have to be probably dependent on the tool, which tool will be able to answer this particular question and will be able to give the context and generate the output. So this is nothing but it is a basic agent. It is a basic agent. Okay, it is a basic agent. This is the simple functionality of an agent. Okay, so that is what an agent is all about. So I hope till now you have got a clear understanding what a basic agent looks like, right? So autonomously here you can see that it is able to make any kind of a simple decision, like when to route what kind of query and how to probably solve that particular task. Okay. So whenever we talk with respect to an agent, before creating an agent with the help of LangChain was a little bit tough, you know. So before we used to use an LLM model, then we used to create a tool separately. Then we had to probably go ahead and do a linkage between this particular tool to the LLM. We used to use a architecture which is called as React architecture. Okay, React architecture. Now, with the help of this particular architecture, we were building this specific agent. But now, creating this agent has become simpler with the recent LangChain version, that is LangChain version 1. Okay. So now let me go ahead and show you that how we can quickly create an agent and how easy it is basically to create an agent. So first of all, in order to create an agent, what we will be doing is that we will just go ahead and define something called as from LangChain. Okay, LangChain dot agents. We import something called as create underscore agent. Okay, create underscore agent. Now, as soon as we write like this, LangChain dot agents create underscore agent, here we go ahead and define agent is equal to create agent, and inside this, first of all, we give our model name. Now, model name can be given through different ways. So directly, if I'm importing the OpenAI library, I will be giving them my model name. Let's say my model name is GPT-5, which is the recent, specific OpenAI model. And then I will go ahead and use tools. So right now, I will keep this tools and empty because I don't have any other tools created yet. Okay. And then apart from this tool, we also provide some kind of system prompt. So here I will go ahead and write my system prompt saying that, hey, you are an helpful assistant. Okay. And then we have also kept verbose is equal to true. I will talk about what is verbose. Okay. It will give you more information with respect to the invocation. Now, as soon as I go ahead and just run or write this, so here you can see it got an unexpected keyword argument. I think verbose is not supported yet for this. So let me remove it. Okay. Now let me just go ahead and execute this agent. Now you will be able to see some kind of diagram over here. Okay. And that diagram will definitely match this diagram that we have created. Okay. So this is how we basically go ahead and create a basic agent. But right now you can just see that tools is right now empty. Okay. So what we have start, we have model, and we have end. So that basically means we just have this input, LLM, and output. Still, that tool connection is not there because we have not created any tool, right? So now what I will do, I will just go ahead and define one function. So let's say this is my get weather function. I will give my city over here, which will be in the form of string. And this will also return string. Okay. And here I will just say return the weather in this city is sunny. That's it. Okay. I can also provide some docstring to provide some more information related to this particular function. It's like get the weather for a city. Okay. And now this same tool, I can add it over here. So that basically means if I ask what is the weather of Bangalore, now the LLM will be much more smarter enough to know that which tool it needs to call, right? So now what I have done is that we have created a function which is called as get weather. Okay, so here what we have done is that we have created a function which is called as get weather, and this get weather is added as a tool to this particular LLM. Okay. Now, if I ask, hey, what is the weather for this particular city? Now the LLM will make a decision. It will not have the current information, obviously, right? Because it is always trained with the previous data. So it knows that it has to call this get weather function or tool, right? And then it will try to get the context. The context is nothing but whatever this function is returning, that is the context, and finally it will be generating the output. Okay. Now see this. As soon as I created a function get weather and I updated inside this tools, right? Now I have this tool that is available. Now you see how this agent diagram will change. Now you can see that, right? So now I have start, the model, which is my LLM, and this is basically connected to my tools. Now, whenever I ask any question with respect to weather, this model will definitely go ahead and hit the tool, get the response, and it will display as the output. Now, in order to run the agent, It is very simple. I will go ahead and run the agent over here. And running the agent is very simple. I will write agent.invoke, agent.invoke. And let's say that I will go ahead and just write what is the weather like in New York. I know this is not going to give me New York weather because here I'm just returning a simple string. But just imagine that here we had some API calls that was basically made in order to get the weather information. And here we can display that particular information. So now if I go ahead and execute this, clearly you will be able to see that I'm getting one error. Let's see. Expected dictionary. Okay. So this is not the right format to give it. The simple reason is that we need to give it in the form of messages. So I will write messages colon. Okay. And then I will give it in the form of a role. Like a role is like user because it is a user message, human message. We will talk more about this different types of messages as we go ahead. But right now, I just want to show you how you can go ahead and run this particular agent. So role is equal to user and content we are writing. What is the weather like in New York? Now, if I'm giving in this formula, see the error is very simple over here that you have got expected dictionary. So whenever we are using this inbuilt function called as create agent, for creating the agent, in this particular scenario, we have to give the input in the form of a dictionary, wherein my dictionary key will be in the form of a messages. Okay. Here, if I'm writing messages and I'm executing this, so here you can see I'm given the role is equal to user and content, what is the weather like in New York. So if I go ahead and execute it, now you'll be able to clearly see the response. See guys, I'm showing you the error. I will not cut that particular error part because I want to show you each and everything. Okay. So now what is the weather like in New York? So first of all, this was the human message that has gone. You can also give it in the form of human message. We'll discuss more about the messages as we go ahead. Then here you can see the AI message is making a tool call. So somewhere here, you will be able to see that it has made a tool call. So let me just go ahead and see it. Somewhere here you can see that it has made a tool call and it also knows which tool to call, right? Get weather, because it has this particular information. Now the question rises that how does LLM model knows that it has to make a get weather tool call? Because when we define this particular function get weather, we have also put a doc string, right? And when we are assigning this tool to this particular agent, this doc string, the LLM will understand which is the doc string over here, like get the weather for a city. Now it knows that it will go ahead and call this particular function, right? So it made a tool message. So here you can see the weather in New York is sunny. It has just taken this particular city data and it is basically giving you the output like sunny, right? And then finally you can see the AI message, it's sunny in New York, right? So once you get the context from the tool, the model will be displaying the output, right? So if you want to also display the output over here, you can just go ahead and write response is equal to agent this one. And then I will just go ahead and write response of messages, right? So you can see messages and then you can just go ahead and take the last message dot content and here you should be getting the output, right? So when you write messages last one, you will be getting the last output. If you remember, if you remove this also, you'll be getting the entire conversation and all, right? Let me also show you one more way. You can also directly go ahead and write like this agent.invoke and here you can write in the form of messages and here you can just go ahead and write something like this. What is the weather in New York? So let's see whether we'll be able to get the output or not. Like this also you can directly write. You don't need to even specify that whether it is an human message or not. It will automatically identify it. Okay. So now here you'll be able to see that. And there is a small spelling mistake and here also you can see that I'm getting an output. Okay. And this is really, really good. Even though I made a spelling mistake, it is being able to give me the right output also. Okay. So that's the most amazing part out there. So I hope you got a very basic idea of how to create an agent. What was an agent? We basically say this as an autonomous agent because based on the input, the model is taking the decision which tools to call, get the context and give you the output, right? So everything is happening over here. But as we go ahead, we will be creating multiple tools. So this is one of the tool. Like that, we can go ahead and create any number of tools as we like. Okay. So this was just a basic way of creating an agent with the recent version. Now, which version we are talking about with, right? So I'll write import Langchain and import Langchain, and I will just go ahead and print Langchain dot underscore underscore version underscore, right? So it is 1.1.0. So I hope in this video we have understood about agents, basic agents, right? Agents are like, autonomously it will be doing this specific task that is assigned to it. So yeah, in the next video, now we will see how to integrate different models. We will talk about different kind of messages, each and everything. And as we go ahead, like in this series, we will be discussing about that. So let's go ahead and discuss the next thing, that is model integration. So guys, now we are going to discuss about model integration with your LLM application or with your generative AI application. And we will see three popular models, that is OpenAI, Google Gemini, and Grok. In Grok, you have various open source models. Google Gemini, whenever we talk about, there are different Gemini models, and OpenAI, like you have GPT models, 4.5, 5, whichever you want to specifically go ahead and use it. Okay. Now, what we are going to do is that I will just go ahead and show you with the recent updated LangChain, like what are the different ways of invoking a specific model. Okay. So first of all, I will go ahead and make a code cell, and if you remember in our .env file, we have all the three API keys loaded over here. Okay. So first thing is that what I will do, I will just go ahead and write import OS, and then from .env import load underscore .env, right? And I will go ahead and initialize the load underscore .env so that we load all the models, right? And then we are going to set our environment variable from the OpenAI API key. So OpenAI API key is equal to os.getEnv, and here also we are going to use the OpenAI API key. Similarly, what you can actually do is that you can also load different API keys, like how you have seen over here, Grok API key, you have Google API key and all, right? So we will be using all these three models, and we'll try to see that how we can go ahead and call them. Okay. So once I have initialized, or once I have loaded all the environment variables, specifically with respect to OpenAI API key, Google API key, and Grok API key, first I will show you how you can load the OpenAI model, right? So for this, first of all, I will go ahead and initialize from Langchain dot chat underscore models import init chat model. Okay. So init chat model is one of the libraries that we specifically use in order to initialize any kind of chat model itself. Okay. Then we go to the next statement. We will use a variable called as models. So let's say I will write model, and here I will write init chat model. And by default, you can directly provide your model name. Okay. Now, since I want to show you with OpenAI, so first of all, I will go ahead and write GPT. Let's say I want to go ahead and try 4.1. Okay, 4.1. And here, I will just go ahead and write models. Okay, instead of writing models, I can also go ahead and write model. And now let's see what error I get. Okay, unable to inform provider for model is equal to, GTP I have written. It should be GPT 4.1, right? So I hope everybody knows different models that are available in OpenAI. You have 4.1, you can have 4.5. Okay, so I will be using 4.1. So here you can see that now once I execute this, it gives me this information that it is a chat OpenAI model. It has maximum output tokens, all this information over here with respect to the model. Now comes like, how do I go ahead and invoke the model? So let's invoke the model over here. Now, in order to invoke the model with the help of init chat model, or directly, you can directly use this model.invoke. And let's say that I give a message saying that, hello, how are you? Okay, how are you? Now here you can see that clearly I've given a simple message. This is a human message itself, and I will be able to get the response. Now let's go ahead and display the response. So this is a simple, like I'm giving this specific input. This input goes to the model, that is GPT 4.1, and it'll give us some kind of response. Okay. Now once I go ahead and see the response, you will be able to see that I get an AI message content. Hello, I am just a program, but I'm here and ready to help you. How can I assist you today? So this is the response from the LLM model, that is GPT 4.1. Okay. If I really want to just directly see the content, I can also go ahead and write response.content. Okay. Once I do this, this is the output of the model that you will be able to see. So any kind of models that you have with respect to OpenAI, let's say I want to go ahead and try GPT 4.5, you can go ahead and change this. Whatever model you require or whatever model you really want to use from OpenAI, you can change the model name and you can actually get it over here. Now comes the next one, like how do I call a Google Gemini model, right? So here I'm going to talk about Google Gemini model integration. So let's try this also. Okay. So for Google Gemini, what I will do, I have already loaded the environment. So I will write from Langchain dot chat underscore models, import init chat model. Okay. So init chat model, and here I can use this. Okay. So this is a markdown, right? So I will delete this and let me execute it over here. A lot of suggestions usually comes with this Google anti-gravity, and I specifically use this. I like it because for coding purpose, it becomes easy for me to quickly, auto complete all the code. So now what I will do is that I will go ahead and just use this specific code. Now see this code. So I'm using from Langchain.chat models, import init chat model. Okay. Here we are loading the Google API key, and then we are using init chat model. But to specify this Google Gemini model, we just have to write Google underscore Gen AI colon whatever model name you are specifically using from Google Gemini, right? There may be different models. So I will use Google underscore Gen AI colon Gemini 2.5 flashlight. That will be model. And I've just written model.invokes. Why do parrot talk? So this is the question that I have given from the human. I get the response and I will just go ahead and display the response. So once I display the response, now you should be able to see that the output that you're getting will be from the Gemini 2.5 flashlight. Okay. So I have already initialized, I have already loaded the Google API key. For the first request, I think it is going to take some amount of time. But after that, if my API key is absolutely working, I'm actually going to get the response. So this is how you can use init chat model and integrate with Google API key. So here you can see that I have got the answer. Parrots don't talk in the same way human does, with understanding intent behind every word. Instead, they are remarkable. Something like that, right? So this is the output from the Google Gemini 2.5 Flash. Now, I also want to show you, instead of using init chat model, we can also use one more way. Okay, and that is basically by using chat OpenAI. Chat OpenAI. Now, in order to use chat OpenAI, what I will do, first of all, I will go ahead and see in my requirement.txt, okay, requirement.txt, do I have the necessary library that I'm actually looking for? Okay. Now, you may be thinking, Krish, what kind of libraries that you specifically require, right? So here we already have Langchain OpenAI, So Langchain OpenAI is basically installed or not. So first of all, you have to probably go ahead and check that. So if that is installed, I think you are good to go over here, right? Now for chat OpenAI, if I really want to use, what is the library that I need to import, right? So here I will go ahead and write from Langchain underscore OpenAI, import chat OpenAI. Then we will go ahead and initialize chat OpenAI. And here I'm just going to go ahead and give my model name. So model is equal to, and let's say I will just go ahead and use GPT 4.1. Okay. So this is my model is equal to, and then if I go ahead and just write response is equal to model.invoke, let's say I go ahead and write, hello, how are you? I should be able to get the same output like how we got it over here. Okay. So using init chat model basically gives you an option of indirectly using this chat OpenAI. See here also, when you see this specific model, it is nothing but chat OpenAI. So there is also one more way of basically calling this particular model. Now, since you have chat OpenAI, and in the requirement.txt, you have also installed Langchain Google Gen AI. So here also you have an option of something called as chat Google Generative AI. Okay. So if I go ahead and paste it, you can see from Langchain underscore Google underscore Gen AI, import chat Google Generative AI. I've used again Gemini 2.5 flashlight. Why do parrots talk? If I go ahead and see the response, uh, this kind of suggestion will come, so don't get worried about it because we are not going to use the suggestion over here. Okay, so here is my output from this specific Google Gemini integration. Now, these are the ways you can either use init chat model, you can use chat OpenAI if you're specifically using OpenAI models. If you want to go ahead and use Google Gemini models, then you can use chat Google Generative AI, or within the init chat model, you can go ahead and call the Google models itself, Gemini models. Now, the third one that I am going to use is Grok model integration. Now, similarly, Grok model integration will also be very, very easy. Okay. So again, two ways. One is by using init chat model. So here you can see now, I am imported init chat model. I have my environment variable set up for Grok API key. And then you can see I'm using init chat model with my Grok. Now this time I'm writing Grok over here. See, before I wrote what over here? Google Gen AI and the model name of Google Gemini. But here, this time we are writing Grok colon, whatever model we want to specifically use from Grok, right? That Quen is the recent model that has been uploaded over this. I used this. And then we are using model.invoke. Why do parrot stock? I'm able to get the response. Okay. Now you have init chat model, so there should also be an option of chat grok. Okay. So that will be my next one to show you. So here you can see that I'm getting the output. Okay, so why do you parrot stock? Let me think about this. I know parrots are mimicking human speech and all the information is over here. Now, one more way that how we can basically call chat grok. So here you will be able to see we can use Langchain underscore grok. So again, in the requirement.txt, you can see we have imported Langchain underscore grok. So I've imported from Langchain underscore grok, import chat grok. I'm calling the same model and I'm able to get the response. Okay. So here you will be able to see that I'm able to see the output with respect to the same thing. Okay. So this is pretty much clear, I guess, with respect to the model integration. I think we have done a pretty good job with respect to this. And all the integrations specifically, two ways of simple integration of calling loading the model is from init chat model. Or let's say if you are using OpenAI, then we use chat OpenAI. If you are using Google Gemini, let's say inside the init chat model, you just write Google Gen AI, and then you basically write the model name, whichever model name you. So this you can change. I can also use Gemini 2.5 Flash. Let's say I want to go ahead and use this Flash. So here also I should be able to generate the content. It's like a very, very easy approach of calling any kind of model specific to the LLM providers. Okay. So here you can see all the outputs you are basically getting. Okay. So this was about model integration. Now in my, as we go ahead in this series, we will also be talking about the message structure, the streaming structure and all. Okay. So probably in this series, now we should also go ahead and understand the streaming structure. So let's go ahead and discuss about that. So now we are going to discuss about these two important topics, which is called as streaming and batch. Okay. Now, why streaming and batch is important? So let's say that I go ahead and write model.invoke. You know how to invoke a specific model, right? And let's say that I say, hey, write me a 200 words paragraph on artificial intelligence. So let's say if I'm asking this question to my model or to my LLM, right? And here you will be seeing that we have to wait for the response to get generated and be displayed over here, right? So this usually happens in invoke, right? But it is always a good practice that we try to stream the output as soon as it is generated from the LLM, right? So, and that is where streaming can be very, very handful. So here you can see most model can stream the output content while it is being generated. Now in this particular case, we had to wait till the LLM completely generated the content and then finally it displayed the output. But in the case of streaming, what we do is that we can also stream the output of the LLM model while it is being generated. So by displaying the output progressively, streaming significantly improves user experience, particularly for long responses. So for this, we have to use this function which is called as stream. Okay. This returns an iterator that yields output chunk from the LLM and they also display it over here. So let's try to see that how this stream will basically work, right? Now, in order to do or work with streaming, we will be using this inbuilt function called as model.stream. Okay. And let's say now I go ahead and ask, hey, write me a 200 words paragraph, okay, on artificial intelligence. So let's display this right now. Okay. Let's execute this. So here you can see that it is creating a generator object, but our main aim is that this is of a stream type, right? We also need to display the output from the stream. So what I will do, I will use a for loop. So I'll say for chunk in model.stream, and let's display the stream output. Okay. So here I will go ahead and print, and I'll just go ahead and write chunk dot text. Now let's display this. Now here you can see that once we go ahead and execute this, it did not wait for the entire content to be generated. So what we have done is that as the content is being generated from the LLM is giving you the output. It is also getting displayed over here. Okay. In a much more better way for you all to see, what I will do, I will use some special character to just, show you the content that is basically generated. So I will use this 2 parameter end is equal to, that basically means I'm using some kind of delimiter over here as soon as any token is generated from the LLM. And we are also going to use flush is equal to true. Okay. Now see the output. I've written write me a 200 word paragraph, and here you can see that we are generating this particular text, and this text is basically getting generated over here. Okay. Now let's try some more good things inside this. Instead of just writing like this, I will also go ahead and just try to display something over here. So let's go ahead and do this. And here you can see that I'm just writing, why do parrots have colorful feathers? Okay, feathers. So now it is going to print the chunk.text, and here you can see that paragraph by paragraph, as the content is basically getting generated, it is also being displayed in the output. So this is an example of stream. And the main thing is that you can stream the output from the LLM while it is being generated, right? So we don't have to wait till the entire text is generated. Now, if I go ahead and ask the same question over here, so let's say I go ahead and ask the same question, and here instead of, why do parrots have colorful feathers, if I just go ahead and use model.invoke. So here what I will do, I'll remove all these things. Okay, I will remove all these things, and we will try to generate it by using model.invoke. Now see, we have to wait for the output. Okay, model.invoke, it is giving me some syntax, no worries, I will fix it. Now see, I'll wait for the output. I'm waiting, and then finally the response gets generated, right? Once the entire output is created, then only it will get generated. But in this case of streaming, as it is generated, we are also able to see. Okay. Now, similarly, there is also one more concept which is called as batch. Okay. Now, batch is a collection of independent requests to a model which can significantly improve performance and reduce cost as the processing can be done parallel. Now, there may be a scenario that you may have multiple inputs. So let's say I will go ahead and create some kind of response. See, I'm using model.batch function. Inside this, I have a list of inputs. Like my first question is, why do parrots have colorful feathers? I'm writing, how do airplane fly? What is quantum computing? Now I have 3 different questions, and I want to send all this question as an input to the LLM model in a parallel way, right? I want the output parallelly, right? So that is what it is over here. You can see batch is a collection of independent requests to a model which can significantly improve performance and reduce cost as the processing can be done parallel. So if I'm giving 3 inputs, this will go parallelly to the model and generate the output. So let's go ahead and see the output now. Here you can see all these 3 questions has gone together by using this model.batch, and automatically you'll be able to see all the output all at once. Okay, 3 responses it will generate, and you're able to see the output all at once. Similarly, I can also set one more parameter inside this, which is basically called as max currency, right? So there is a config parameter which you can basically add along with this model.batch functionality, which says that how many parallel calls you can actually make. So here you can go ahead and set it, max concurrency is equal to 5, and then probably go ahead and do it, right? So anyhow, my questions are 3. If I'm giving 10 different questions all at a time, so it will take 5, and then it will probably send it to the LLM and generate the output, right? So I hope you got a very clear idea about streaming and batch. And this is necessary because if you are working for any company developing chatbots, most of the time you are definitely going to use streaming, but there may be scenarios that you also want to probably go ahead and use batch functionality. So I hope you like this particular video. So I hope you have understood this. Now let's go ahead towards the next section wherein we are going to understand about tools creation. So guys, till now we have already discussed about streaming and batch. And along with this, we also saw the model integration, like how you can go ahead and integrate different kind of LLMs with the help of two important functionality or two important libraries. One is init chat model. And you can see that we have also used chat Grok, chat OpenAI, and along with that, we also had chat Google generative AI, right? Now it's time that we move towards one more step ahead and we talk about how to go ahead and work with tools. So if you remember, we had discussed about a simple agent, right? In an agent, basically an LLM will be connected to a tool. Now this tool is just some kind of functionality. It can be a API request, it can be inbuilt tools, it can be news reporting tools, it can be Google search engine tool, it can be any kind of independent functionality tool, right? Now, in this series of videos, now we are going to understand like how we are going to go ahead and create tools, right? So first of all, what I will do, I will go ahead and create a IPYNB file, and here you can see tools definition is basically given. Model can request to call tools that perform tasks such as fetching data from a database, searching the web, or running code. Tools are pairing of a schema, including the name of the tool, argument and definition, and function or coroutine to execute. So here, what we are basically going to do is that, first of all, I will show you how you can basically create a tool, right, in a simple way. So first of all, as usual, I will use one of my LLM model. The LLM model that we are going to use is Grok Qwen 332B. And here you can see that I'm also able to invoke the model. This we have already learned in the previous section, right? So inside this response, you will be able to understand like what is the response that you're getting from the LLM. But with this particular model, I need to integrate some tool, okay? Now, in order to integrate, what tool I will first of all create and what is the basic schema definition for creating a tool. So whenever we need to create a tool, first of all, I will go ahead and, use a import function from langchain.tools. I will import something called as tool. Okay. Now this tool library that we are importing over here will be used as a decorator. So when we use this as a decorator on the top of any function, that function will actually become a tool in Langchain. Okay. So here, first of all, we'll write @tool. I will go ahead and define my function. Let's say this function is nothing but get weather. Now inside this get weather, I will be using a variable which is called as location, and this will give you a string type. Okay. And here I will also go ahead and define, see, if you see the definition, whenever we talk about tool, it is nothing but it is pairing of schema, including the name of a tool, description, and or argument definition. So here I am going to go ahead and provide some doc string. Now this doc string will play a very important role. I will talk about it. Okay. So I'll say at a location. Okay. So get weather at a location. Now this definition, this schema that we have, or this doc string that we have defined over here, this is important because when we bind this tool with the LLM will be able to identify the functionality of this particular function. Okay, what exactly it is doing from this particular doc string. Okay, so that's the reason we have written this doc string. So now I will go ahead and say return, and here you can write any functionality that you want. Okay, so let's say I'm hard coding right now the temperature. What you can actually do is that you can go ahead and hit a API request or database request over here and get the information. So I'll write it's sunny in this specific location, which location I'm actually using. Okay. By default, I'm saying it's sunny. Okay. Now this is done, right? I have a tool over here. Now this tool needs to be binded with my model, right? So if you see over here, if I want to bind this LLM with this particular tool, how do I do it? Okay. So for that, I will be using model dot bind tools. Okay. So bind tools. And here we are basically going to use this particular tool, which is called as get underscore weather. Okay. Get underscore weather. And here we can go ahead and write model underscore with underscore tools. Now this is one way. Okay. The other way is that what we have learned, right? We can directly use this. We can use this function, right? Create agent, give the model name, give the tools, and automatically this will get created, right? That we have already shown. And this is one of the functionality which we used to use before also. That is nothing but binding tools. Okay. Now, once I bind this tool, the next thing is that how do I call this? Okay. See, now in order to call it, I will say model with tools dot invoke. What's the weather like in Boston? And here now I can go ahead and iterate through this response tool calls. See, if I just go ahead and print the response, first of all, you'll be able to see. I'll print this response. Now, when we are printing this response here, you will be able to see that the reasoning content is this: the user is asking for about the weather in Boston. I need to use the get weather function. See, automatically now LLM is able to make a decision that what functionality needs to be called. And here you can see that we are also printing the tool calls that it is doing. So tool call of name is nothing but weather, and argument it is basically requiring is nothing but location. Okay. So this is the most simplest way of working with a tool. Just directly go ahead and use a decorator, provide some kind of schema or docstring, and just go ahead and bind it with the tool. Either you can do like this, or if you're directly creating an agent, you would just define that particular schema, means the function, and then you use this create agent with the model name, with the tool name, and here you will be able to get it, right? This is the most simplest way. Okay. Now, I really want to show you one more important technique, which is called as tool execution loop. Tool execution loop. Now see, first of all, inside this, what I will do, I will paste this code. Now see, initially we set up a message from the role user saying that the user is sending the message, what's the weather in Boston? Now we are using model with tools dot invoke of message. Then here I will be getting my AI message. And inside this message, we are also appending this particular AI message. And inside this AI message, it will be nothing but it will be a tool call, right? We are making a tool call, which is nothing but weather data, right? We are making a tool call over here, right? Now for tool calls in AI message dot tool calls, now that get weather dot invoke of tool call we are doing. See, at the end of the day, if you see, whenever we make a tool call, we are basically calling get weather. And internally, we are using this get weather dot invoke of tool call so that we get the response from this. See, over here, if I go ahead and show you, when we are making the tool call will go ahead and provide us the output that is nothing but the context. And with the help of this particular code, get weather dot invoke of tool call, we are getting the tool results. And that also we are appending it inside our message. And finally, you will be able to see the message text since we are using model with tool dot invoke. Now see, I will execute this step by step. You'll be seeing the weather in Boston is sunny, right? And if you go ahead and just see this messages section, you should be able to see the role, the AI message that you got, and the tool message. Like when the tool got executed, it is giving this particular response, it's sunny in Boston. So when model with tools dot invoke it is going, it is basically getting the context from the tool and it is displaying the output, right? So that's easy with respect to the tool execution loop. Okay. So I hope you got an idea with respect to tools. Very basic way of creating this. Now, the main thing is that internally you can write any definition. You want to use inbuilt tools that are available in Langchain, you can directly go ahead and write the code. The most important thing is that what response you are basically generating out of that particular tool, right? So this was a quick revision on understanding about how you can actually specifically work with the tool. So now, as we go ahead, now we are also going to discuss about one more important thing that is called as messages. Now, what are the different types of messages? There is something called a system message, AI message, human message. So that part we will go ahead and discuss it. So yes, let's go ahead and discuss about that. So guys, till now we have covered various topics specific to tools and how you can integrate tools with the LLM models, um, and probably go ahead and create a generative AI application. Now we are going to move towards our next topic, which is called as messages, right? And messages, in short, are a very important data structures that can be specifically used with LangChain. Uh, I have written the definition. I will go ahead and write the code in front of you. Each and everything we'll discuss step by step. So first of all, the messages are the fundamental unit of context for models in LangChain. They represent the input and output of a model carrying both the content and metadata need to represent the state of a conversation when interacting with an LLM. Messages are objects that contain role, content, and metadata. Role is super important. Okay. Role basically identifies the message type. Now, first of all, what I'll do is that in order to show you the messages, till now we have discussed in various places, right? You can see that I'm getting an output with respect to tool. So this is one kind of message. Whenever you see an output from a specific model, right? Like here we have written model.invoke on a specific question. The model, when it is giving its output, will be in the form of a message. So whenever a model gives an output, it is basically a AI message. Whenever a human is giving an input, it is nothing but a human message. So there are different kind of message structures that we are going to see. There are specifically 3 types which we are going to discuss one by one. Okay. So first thing first, what I am actually going to do, first of all, I will go ahead and initialize my model. Okay. Now you know how to initialize your model. So I have imported OS from langchain.chat_model, import init chat model. I'm using the Grok API key as my environment variable. And then we have used init chat model with this Qwen model from Grok. Okay. So I'll go ahead and execute this. Now see, this is really important. Okay. Whenever I go ahead and write model.invoke on any specific input. Okay. So let's say I'll say, please tell me what is artificial intelligence. Okay, so this is my question. Now, by default, when I give this specific input to the model, this is treated as a human input or a human message. So once I execute this as an input to the LLM is going as an input, which is nothing but a human message. And when I want to see the output, I'll just go ahead and execute this. Now my output will be basically an output from the LLM, which is nothing but an AI message. And the content that is inside this is the output from the LLM model. Okay. Now, this is what a simple message basically looks like. Now, 2 things we have discussed about: human message, AI message. I will deep dive more into it and probably talk more about it. Okay. But first of all, before going to human message, AI message, we will start with a text prompt. Okay. So text prompt are nothing but they are strings idle for straightforward generation task where you don't need to retain conversation history. Okay. Now here you can clearly see that whenever I'm writing model.invoke with some specific question. Okay. So here when I'm writing model.invoke with some question, let's say I'll say what is LangChain. Okay. Now in this particular scenario, I have not specified anything to the model, like how the model should behave, right? I'm just providing a simple text, right? This text is treated as a human message internally, but I can also say this as a text prompt. Okay. So idle for straightforward generation task where you don't need to retain any conversation history. Let's say that I just want to give an input and get an output from the model. So in this particular scenario, I will just go ahead and use this phenomenon, right? So when I say model.invoke, what is LangChain? I will directly get an output in the form of AI message. Okay. Now use text prompts when you have a single standalone request. You don't need conversation history. You want minimal code complexity and all, right? Now we will see in the different type, like one more category, which is called as message prompts. So here we have seen about text prompts. In text prompts, I just specify my input. I get the output from the model. So now we will try to understand how is message prompts different than the text prompt. Okay. Now here we'll first of all see the definition. Alternatively, you can pass messages in the list of messages to the model by providing a list of message object. Okay. Now you need to first of all understand, if I want to provide a list of messages, it can be a human message, it can be an AI message, it can be a system message. Now you should understand what exactly is a system message. System message is just like an instruction, like how the LLM should behave. Okay. Again, let me repeat it. What is a system message? It is nothing but it is a kind of an instruction to the LLM, like how it should basically behave. So in the case of message types, you have different messages like system message, human message, AI message, and tool message. First of all, we'll understand the definition of system message. System message tells the model how to behave and provide context for interaction. Human message is nothing but it represents user input and interaction with the model. AI message is nothing but response generated by the model, including text content, tools, and metadata. Tool message represents the output of a tool call. Okay. So all this information is basically over here. So here you can see system message, definition, human message, AI message, and tool message. So let's go ahead and see this particular example. Okay. So first of all, what I will do, I will go ahead and import all these messages types. So in order to import, I will use from Langchain dot messages, import system message, human message, comma, AI message. Okay. Now I will create a list of messages. Let's say that I am having a conversation history also. So that's the reason I'm creating this list of messages. So let's say first of all, I use a system message. Now this system message is just like an instruction to the LLM model, like how the LLM model should behave. So I'll go ahead and write, you are a poetry expert. Okay. So this is my first message. Let me go ahead and write human message over here. In the human message, I will go ahead and say, this will be a human input. I'll say write a poem on artificial intelligence. Okay. Artificial intelligence. Because in chatbot, usually this kind of conversation happens in a conversation history, right? There'll be a list of messages that will be happening. So let's say here, I give the output, or let's say I give this two information, like a system message and a human message. Okay. So this is my list of messages. Now I'll use model.invoke and I'll give this messages over here. Okay. Over here, I'll get it and I'll go ahead and get my response. Now let me do one thing. Let me go ahead and print my response.content. Okay. Now see, this both the messages are basically going. Okay. First is the instruction to the LLM, like how you should basically go ahead and act. Like I'm saying, you are a poetry expert, and then probably I've given the input, and based on this input, I will be getting my AI message as the output. Okay, the user wants a poem about artificial, and let me start thinking about the key themes related to AI, creating aspects, how human build AI, then maybe do, and all this information is basically there, and you're getting the output. Okay, so this is what a simple a list of messages prompts look like. Okay, here we can pass a list of messages in the form of a conversation history. Here I can also go ahead and provide AI messages over here and probably go ahead and try it out. Okay, now let's see some more important thing, right? Here the kind of examples that you have seen is with respect to a system message. Okay, this was just a basic message itself, right? You will just have a one liner. Let me see one more example. So here I've written system message. I'm writing, you are a helpful coding assistant. I've given this messages list, human message as an input. How do I create a REST API, right? And now you can also see the specific response. It will go ahead and try to create a REST API. So here you can see all the information. Okay, the user is asking, all this information is basically creating a REST API involves defining endpoints that handle this and that. All the information is there. Okay, so that basically means we are able to get a good answer. Now, till now, the system message that we have specified is just a one-liner message. Sometimes we want a detailed information provided in the system message so that we give more information to the LLMs, right? So what we will do, I will show you one more example where we give detailed information, detailed info to the LLM through system message. Okay, system message. So let's see this example. So this example is also really good. So here, now I will say like this. Now see, inside this, we have provided a system message. I'm saying you're a senior Python developer with expertise in web frameworks. Now, more context is basically given. Here, before that, I've just told that, hey, you are a helpful coding assistant. We have not specified any specific programming language like Python, Java, it can be C, C++, anything as such, right? I've just provided a generic information. The answer was also very generic. Okay. But in this particular scenario, you can see that I've provided a detailed information. You're a senior Python developer with expertise in web frameworks. Always provide code examples and explain your reasoning. Be concise but thorough in your explanation. Now I wrote, how do I create a REST API? The same thing. Now you see the response. The response will be much more practical and it will be related to definitely Python. So if you go ahead and see this, here you can see start the steps, choosing Flask, install it, the code example, everything is over here and a lot of messages are over here, disable debug mode in production, add input validation and all, right? So you can clearly see that if we provide more information inside this system message, we will be able to get more proper response. Okay. Now, this is what a simple thing is, right? Now, I have also told you that whenever we provide the messages, we can also provide this three important information. One is role, content, and metadata. Role basically identifies the message type, whether it is system, user, or human. Content represents the actual content of the messages. It can be text, audio, and documents. Metadata is some kind like an optional fields. Okay. So let's say that I want to go ahead and define some kind of human message over here. Okay. My human message with some metadata. So here you can see content is hello, name is Alice, ID is message 123. So here you can see we are providing two metadata information. One is for identifying for different users and one is uniquely identified for tracing. So this is basically for tracing, so that we can go ahead and trace it. Now, if I go ahead and see the response, see, if I go ahead and just use model.invoke on this human message, you should be able to see the response. So the user said hello, so I should be in a very friendly way. It will be able to probably provide the response based on the metadata information also that we specifically have. Okay. Now, this is just a specific idea about how you can play with system message, human message. You can also have AI messages. We have also spoken about the list of messages that you really want to work on, right? Right. Let's see one more example. Okay. Now, this example is also amazing. So here you can see I've written from Langchain.messages. I've imported AI message, system message, human message. AI message is that I'd be happy to help you with the question. Okay, create an AI message manually. We have created it. Okay, this is not generated by AI itself, but we are creating our own message and we are assigning a label as AI message. Now I am adding all the information into the conversation history. So say you are a helpful assistant. I've written as a human input initially. We have written, can you help me? AI message is nothing but I'd be happy to help you with that question. Human message, great. What is 2 plus 2? Now, this entire list of conversation can be also understood by the LLM, and based on this, it should also be able to give you the output. So here you can see clearly how the output is, right? First 2 plus 2 is 4. That's straightforward, but should I explain this? So this is a reasoning model that we have specifically used, right? So that's the reason it is providing a lot of reasoning stuff and all. Now, inside this, can I also go ahead and see my metadata? So in order to see the metadata, so I can write response.metadata, okay, or usage metadata. And here you can see that you'll also be able to get the information like how much was the input token, how much output token was generated by the LLM, and what are the total number of tokens, so that you will be able to see all the information out there, right? So this is also there. Now, we have discussed about all the things. There is only one message that is remaining. That is nothing but tool messages. Now, already in our previous example, we have understood about tools. Tool message are nothing but it's just like an output that is provided by the tools, right? So whenever an LLM require a help of a tool, it will go ahead and make a tool call. And whenever that tool specifically gets executed, it is just going to go ahead and give you the output. Okay. So finally, let's go ahead and talk about tool. Okay. And here I will be taking another example, right? So here you can see I've used AI message and tool message. In the AI message, I have empty content, but we are making a tool call. Okay. The name of the tool that we are going to make is get weather. Argument is nothing but location as San Francisco. And we have also used ID. Weather result, whatever we are basically getting, we have hard coded it. Now I'm using this tool message with content is equal to weather result and tool underscore ID. Now see, I've asked the question, what's the weather in San Francisco? Then AI message is basically given from here. Okay. And then tool message is nothing but the output that we get from here after executing the weather result. So now if I go ahead and execute this and probably go ahead and see the response, I should be able to get the output as, okay. One more very important thing is that if you see this specific tool message, okay. So if I go ahead and see my tool message, it is nothing but it is coming as a tool message, okay. And once this tool message is there, we are giving as an input to the model. So that is the reason model.invoke of messages when we execute, we are getting the response as AI message. So I hope you got an idea with respect to different types of messages. You can go ahead and try it out, explore more about it. Since this is the updated version of Langchain, my responsibility is to cover all this specific topic as the updates are basically coming up. Okay. Now, as we go ahead, we'll also be talking about different structured output where we talk about Pydantic, we talk about nested structures, we talk about Typedict. So that part we will be covering now. So now we are going to discuss about structured output. Till now, we have already seen messages. We have also got to know about the different type of message prompts like system message, human message, AI message, and tool message. And we also saw multiple examples and how to implement it with the help of Langchain. Now in the structured output, why is structured output actually required? Okay. Now see guys, we will definitely be using different LLMs and we want this LLM models to be requested in such a way that so they provide the response in a format matching a given schema. So let's say that, hey, I am requesting a LLM model to write me an essay on some specific topic. And I definitely want the response of that LLM model to follow some structure. And that is where I would definitely want some kind of structured output, right? So this is where we implement or we make the LLM to give a kind of structured output, and we do it by using different techniques. Some of the techniques are like Pydantic. We can also use Typedict. We can use data classes. And that is what we will be discussing in this particular section. Okay. So over here, you can see I have written a very detailed explanation about structured output. It says that model can be requested to provide the response in a format matching a given schema. This is useful for ensuring the output can be easily parsed and be used in subsequent processes. Langchain supports multiple schema types and methods for enforcing structured output. So the first technique that we are going to use, the first type that we are going to use is something called as Pydantic. Now, Pydantic model, it provides the richest feature set with field validation, description, and nested structure. So I will show you one example, like how we can create a structured output from the LLM, specifically for the LLM response itself, right? So first of all, what I will do, I will go ahead and import OS. Along with this, what I am actually going to do is that I will also go ahead and the first step is obviously I have to load my LLM model, right? So I'll write from langchain.chat models import init underscore chat underscore models, right? Then I will write os.environ. And here I'm going to specifically write grok underscore API underscore key is equal to os.getEnv. Since I'm actually going to use my grok API key, right? So I'll write grok underscore API underscore key. Now, the model that I'm actually going to use is nothing but I will be using this grok model, grok colon. The model name is nothing but Quen, and we will be using Quen 3 32 billion parameters model. It's a reasoning model, right? So this is the model that I have. So here you can see cannot import name init chat models. Okay, let's see what is the issue. So here you can see there is something called as init chat model. We had made a different import, but it's okay. We have actually loaded our LLM model. Now, let me quickly show you that how with the help of Pydantic, you will be able to generate a structured output. The best part about Pydantic is that It also has field validation, descriptions, and also nested structure. So first of all, in order to use Pydantic, we need to import one library, which is called as from Pydantic, import base models, okay, comma, field. So this field is what we are going to specifically use in order to use field validation. Now here, let's say I want my LLM to give the output in a some kind of structured schema. Okay. Now what schema it will basically follow. So what I will do for that, I will create, let's say, a class called as movie. And inside this movie, we will inherit with this specific base model. Okay. The base model that we have imported over here. And if you see that, it is nothing but it is a base class for creating Pydantic models, right? And Pydantic model has a very important property that it provides you field validation, description, and it also provides you nested structure. Now, let's say my structured output from the LLM needs to have different fields, okay? So one of the field is nothing but title. So let's say this title should be of only type string, okay? So here we are writing colon string, okay? And this will be of type field. And here I can go ahead and provide some description saying that this title is nothing but it is the title of the movie. Okay. Now see, my LLM needs to definitely generate some kind of output, and it will generate based on whatever fields I'm actually creating over here. And we are going to make sure that this title should only be having string value over here. If it has a numerical value, then it will give us an error, because Pydantic will do this kind of field validation also. Okay, the Pydantic model. Now, similarly, my second field will be nothing but year. Let's say my year is there, and it will be of int type, and I will go ahead and write field. And here again, this will be my description, and I will say, hey, this is the year of this year. This year, the movie was released. Okay, the movie was released. And then coming to the third important, let's say that I want to also create one more field inside this. It is nothing but director string. And again, I can basically say this is a field. Now see, you understand what this field is, right? If you go ahead and just hover over it, and if you see what exactly field is, this is basically providing you a lot of different parameters that you can set, which represents this particular variable, right? The year. Okay. So here I've just given that this particular field is nothing but this is the year the movie was released. This information will be very much important for the LLM, right? Because once we are giving this kind of descriptions, we can also set some other parameters like, we can set alias. This will be very, very handy because it will help the LLM to know in which field it needs to place the output that it is coming from the LLM itself when we are displaying that in a structured output. Okay. So this is my director field. In the director field, I will also go ahead and write some kind of description so that it gives some idea to my LLM saying that, okay, the director of the movie, okay. Then I have my ratings. This is also one field that I definitely want. My rating can be a float value. Okay. It needs to be a float value because it can have different float value itself. And then I have my description. Inside my description, I will go ahead and say the movies ratings out of 10. Okay. Out of 10. Now see, this is the output that my LLM should be generating it. So that's the reason I've created a class called as movie, and it is inheriting base model. Inheriting base model basically means it is just going to go ahead, and if you just hover towards this base model, it is nothing but it is a base class for creating Pydantic models. And one important thing is that this Pydantic model has field validation, description and all. Okay. Now let's me go ahead and execute this. Okay. Now, if I want my model to generate this structured output, so what I will do, I will just go ahead and write model with underscore structured output, and we will give like what structured output it needs to give of this particular movie class. Okay. So this movie class is over here, and here I will go ahead and define model with structure. Okay. Model with structure. So this is what my important model is, Now see, as soon as I go ahead and execute this, okay, I go ahead and execute this. And if you go ahead and just display it, what is this model with structure? It shows that it is a runnable binding. It has uh, information from chat graph model, and then it also has this Pydantic tool parser. Okay. Now this is really important because now I'm going to display how the output will get displayed whenever we ask any question to this particular model with structure. So for that, I will go ahead and write model with structure dot invoke. And here I will go ahead and ask a question. Provide details. Let's say I want the details about the movie Inception. So if I go ahead and use model.invoke, if you remember, model is nothing but it is not having any schema attached, right? So here, if we are attaching any schema or any structured output, it is nothing but model with structure. So if I just go ahead and write model.invoke and I say, hey, provide me the details of the movie Inception. So here you can see this is how is the default output we will get. Okay, once we execute this, see, this is my AI message. Okay, I need to provide a detail about the movie Inception. The Inception probably has to do a concept of planting an idea. So it is probably providing all the details, but I don't want all these details. I want the details in this structured output. I want it in the form of title, year, director, rating, right? So I should be able to get that. Now, if I go ahead and use this model with output dot invoke, and now I want to go ahead and create, I'm asking the same question. See over here, I'm asking the same question, response. Now, if I go ahead and display the response, you should be able to see that I will get in this structured output, right? So here you can see title is nothing but Inception. Year, it got released on 2010. Director is nothing but Christopher Nolan. Rating is 8.8, right? So sometimes now this information I can use it anywhere, right? This is a vague information. It has all the information probably from the internet data that it has been trained with. But if I just want some kind of structured output, which is important for me, because if I'm able to generate this output, I will be able to use this in the same structured manner for some other purpose, right? So our main aim over here is that where models can be requested to provide the response in a format matching a given schema. And here my given schema is basically following this. Now there is very much one more very important thing. Okay. Now see, I'm getting the output over here as Inception, which is in the form of string, integer, Christopher Nolan, and rating. Let's say one very important property about Pydantic is that if this title has some integer value, will have some integer value, then it is definitely going to give us an error. And that is what this field validation is supported in Pydantic. Okay. Because of this field validation, you always need to have values of this title as a string only. For this year, you should have it in the form of integer. If in this director field, you need to always have a string. And in this rating, you can either have an integer or a floating value. If you have some other values, it is going to give you an error. Okay. So that is the most important property about Pydantic with respect to field validation. Okay. So now I hope you got an idea about how does a Pydantic basically work. Okay. Now what I will do, I can also go ahead and create a message output. Okay. Message output alongside parsed structure. Okay, parsed structure. So let's see this example. Now you may be thinking what exactly this is. Okay, so here you will be able to see that I will just go ahead and do the same thing. You can see over here from Pydantic import base model field, I've created a class movie. Here, this is just like an optional field. Okay, and then I have put the description, all the information over here, and model with structure. I've written model dot with structured output movie, and I have written include raw is equal to true. See, one of the feature, include raw is equal to true. Now, what this actually does, you'll try to understand it. Okay, what this feature will actually do. So now, if I just go ahead and execute this, I'll create some more code and see the response. Model with structure.inward will provide a detail about the movie Inception. And remember, we have kept this parameter as include underscore to raw is equal to true. Now, once we get includes raw is equal to true, by default, how the raw message will come, that is also displayed over here, right? The initial raw message, this raw message, like how it is basically getting displayed, that will also get displayed over here. And this is my parsed message, right? Based on the structure. So I can also display that also, and there is also option by including this particular parameter. Okay. Now, along with this, there is also one more important thing which is supported in Pydantic, which is called as nested structure. Okay. Now let's see or let's understand what exactly is nested structure. Let's say I am importing Pydantic and I have this class actor. Okay. So inside the actor, you have two variables, name and role. Obviously, every actor will have a name and role, and it is of type string. Okay. Now, inside my movie, right, there may be multiple actors, right? So what I can do, I can use this direct class inside this. So here you can see I've written class movie details, base model, title, this is the movie title, year, the movie release date, cast will be the list of actor. See, this is the same actor over here, and here I can have list of actors. So that is the reason we are saying nested structure. Okay. Genres list of string. It can also be a list of genres, right? And budget is nothing but a floating point. And here you can see that I've created by default none. Okay. Otherwise, we specifically provide some kind of description, budget in million USD. Okay. Now, this way we are using a nested structure. That basically means inside the movie details, we are using this particular actor. Okay. Now, if I go ahead and use the same thing and ask the same question, model with structure output, and this time I have written movie details right over here. Now, if I just go ahead and ask the same question from this particular structured output, saying that, hey, model with structure dot invoke, provide the details about the movie inception, I should be getting the response in this specific way. And in the cast, I will be getting a list of actors. In genres, I'll be getting a list of genres, right? So here you can see, I will just go ahead and display this. This is amazing. See, in title, I got Inception, year 2010, cast, actor name, Leonardo DiCaprio, role, Dom Cobb, right? Then the next actor is nothing but Joseph Levitt, role is Arthur, actor name. So here you can see multiple actors are there. Genre also, you can see the list of this is there, science fiction, action heist, and budget is 160.0. 160.0 based on the millions budget in millions USD, right? So 160 million dollars were actually spent in this. So I hope you got a specific idea about Pydantic. The main aim is that you're providing field validation and you're actually making the model to provide the response in a format that matches your given schema based on the schema that you have actually designed. So I hope you have understood about Pydantic. Now, in as we go ahead, we'll also be discussing about one more type, which is called as Typedict, and there is also one more type which is called as data class. Okay, so we will see both of them as we go ahead. So, guys, now we are going to continue the discussion for the structured output. We have already covered how we can make an LLM to provide a response in a format matching a given schema using Pydantic model. Now, the same thing we will try to do it with the help of Typedict. Now, Typedict provides a simple alternative using Python built-in typing, idle when you don't need runtime validation. So, whenever we are trying to use Typedict, their runtime validation is not there as how we had in Pydantic models. Okay. So now we'll try to do the same thing, like how an LLM can provide a response in a specific schema, wherein runtime validation is not required. Let's say if I'm actually creating title and we are saying that it is of type string, if integer is also getting displayed in the output, it is fine because there we do not focus much on runtime validation. Okay. So first of all, to do this, I will go ahead and use from typing extension, import Typedict. Okay. So we are going to use Typedict. And along with this, I'm also going to use annotated. So these two are the important libraries that I'm actually going to use. If you see Typedict, it is a simple type namespace. At runtime, it is equivalent to a plain dictionary. It is just going to create a simple dictionary in short, right? So that is the reason we don't need runtime validation over here. Now, I will try to use the same kind of data. Okay, so here I will say, hey, let's create a class which is called as a movie. Okay, so now I will just go ahead and create it. Now here you can see I've created a movie dictionary, and this is this time inheriting Typedict instead of Pydantic, right? If we inherit Pydantic, then this all will have a runtime validation, but we right now don't require it. We are saying that, hey, we are going to probably go ahead and inherit with Typedict itself. Okay. And here, first of all, my first field is title. and we are annotating it saying that it is a string and the description is this. These are some optional fields which we can keep it as empty. Okay. So the next field over here, it will be of type. We are annotating it as int, and here you can see the description is mentioned. Similarly, I have director and ratings. Okay. So this is how we actually create this particular structure. So now once I have created this schema, now it's time that I will call my model and I'll use with structure output, and I apply this particular schema, that is movie dictionary, okay, which we have created it over here. And I will just go ahead and say this is my model with Typedict structure, okay, with Typedict, okay. I'll just go ahead and write this. Then the next step will be that I will use this model with Typedict dot invoke, and I'll say please provide the details of the movie Avengers. Let's say this time I'm going to take the Avengers movie, okay. And then if I go ahead and see the response, okay, and then you will be able to see the response over here. So here you can see director Joss Whedon, rating 8, title Avengers, year 2012. Okay. So now you can see the response over here. Now what I will do, I will also go ahead and create a nested structure. And this time, instead of using base model, I will just directly go ahead and use my Typedict. Let's say I will go ahead and use my Typedict over here. I'll use my Typedict over here. So we can also go ahead and implement the nested structure. And over here, the validation will not be compulsory, right? Let's say if the director is having string, if I give an integer, then also it is fine. So here the input validation will not happen like how it happens in Pydantic. So if I go ahead and execute this, so here you can see I'm able to see, please provide me the details about the movie Inception. So 60 million, 160 million, all the information is there. Let's say I want to go ahead and try out for Avengers. So you should be able to even see the response. Okay. So this was a brief idea about how we can quickly use the Typedict. All we are doing is that whatever schema we are actually creating, we are inheriting that specific module, right? In over here, we are using Typedict. In the previous stage, we used base model, which was specifically for Pydantic itself. Okay. And this gives you a clear idea like how we can actually go ahead and use Pydantic over here clearly and how we are able to see the output. Now, along with this, there is also a very important property which is called as profile. So if I write model with structure dot profile, or instead of writing model with structure, I'll use model with Typedict dot profile. And if I just go ahead and display it, here you can see runnable sequence has no attribute profile. Okay, so this is what is the error that we are getting. Now, whenever we try to create some kind of structured output, there we should not be able to see the profile. But if I go ahead and write model.profile, which was my base model, here you can see that all the necessary information, like how many maximum input tokens are there, maximum output tokens, this specific model can actually do. Image input, does it suppose image, right? The answer is false. Audio inputs false, video input false, audio input false, reasoning output true, tool calling true. So these are the information which talks about like what all things the model is basically supporting. And we have used Qwen3 model over here. So Qwen3 model actually specifically has all this particular supporting tools or supporting features which you can actually understand about the model also, right? So now we have understood about Typedict, we have understood about Pydantic. Now the next thing that we need to understand about one more way, like how we can go ahead and apply this kind of schema, that is called as data classes. Okay, so now let's go ahead and discuss about this data classes. So now let's go ahead and discuss about data classes and how we can actually go ahead and how our LLM can create a structured output based on a specific schema with the help of data classes. We'll be discussing about that. Now see, data class has already been there from Python 3.7 version. Okay, so a data class is a class typically containing many data, although there aren't really any restriction like data validation, nothing as such, input data validation, but you can create it by directly using this particular decorator. So let's do one thing. Quickly, let's take one example. First of all, we'll start with Pydantic, okay? Because we have already know about Pydantic now, okay? And here we are using GPT-5 for creating the agent. So what I will do, I will just go ahead and write import OS, and I'll say os.environ, okay? Environ. run. And this time I'm just going to go ahead and use my OpenAI API key, OpenAI underscore API underscore key. I'm using this just to show you how we can actually go ahead and create our agents also. Okay. OpenAI underscore API underscore key. Perfect. Now this is done. Okay. And here you can see that I have imported Pydantic import base model. And already in this series, we have covered how to create an agent, how to create a simple agent. So from Langchain.agents, we are importing create agent. So first of all, I have this particular schema, contact info. We are inheriting base model. Whenever we inherit a base model of Pydantic, that basically means we have some kind of input validation. Name should always be string, email should always be string, phone should always be string. Okay. Then we are creating this agent over here. So here you can see create agent and the response format. Okay. This time I'm not using this with structured output. Instead, what I'm actually doing, I'm directly showing you how you can integrate with the agent itself. So in create agent, model is equal to GPT-5. We are using this model and we are writing response format is nothing but contact info, this specific class. Okay. So whatever agent this is basically there, we are going to always get the output in this particular schema. Okay. So here we are written agent invoke message role with user contact extract contact from john@example.com with this particular information. So here this is my entire content. Okay. And I've written extract contact info from this particular information. And this information is going to my agent. Now agent, what it is basically going to do, based on this particular format, it is going to take the name over here, email over here, phone number over here, right? And then we can go ahead and print the result structured response, whatever response we have, right? So let me do one thing. Let me first of all just directly go ahead and display the result. Okay. So my result is nothing but over here. You'll be able to see quickly after I use this particular model. So here you can see message, human message, extract contact info from this, AI message is over here and structured response is over here. So if I just go ahead and write result of structured underscore response. Okay. So here you will be able to see this is my contact info. The name is John Doe. Email is john@example.com and this is there, right? So based on this specific schema, we are able to get this. That is the useful property about Pydantic. Over here, validation is applied on every field. Okay. Now, similarly, if I want to do it Typedict is very simple, which we have already discussed. So this is nothing but with the help of Typedict. Because I really want to make that comparison. So from typing extension import Typedict, then we are using from Langchain.agents create agent. This is my schema. This time we are inheriting Typedict. Over here, the data input validation will not get applied, but definitely we have provided a schema wherein we are saying the name should be string and all. So here you can see create agent. I will remove the tools. I don't want the tools right now. So create agent with model GPT-5, response format is contact info. Now I have written extract contact info from this information and I will just go ahead and print my structured response. So here should also be able to see that I am able to get the output, which looks something like this in the form of a dictionary pair, right? Like it will be in the form of a dictionary. So that also you will be able to see it. So here you can see name, John Doe, email, example and all. Now I will show you how with the help of data class, you can do the same thing. Okay. So now I will show you with the help of data class. So with the help of, these are just different ways you can use any one of them. So first of all, what I'll do, I will go ahead and import from data classes, import data class. Okay. Then I will go ahead and import from Langchain.agents, agents, import create agent. Okay. And then I will write @data class. I will create the class as contact info, whatever class I have. So this will be my contact info class. And how we define a variables inside my data class. So it will be nothing like this. We just specify the information over here, right? So this is my data class. So let me write it properly because of the validation. So here you can see that I've used name is equal to str, the name of the person, email str, phone number str. Okay. Now the next thing is that I will just go ahead and use create my agent. Here you can also call tools if you have any kind of tools. I don't have any tools, so I'll remove this. But the response format will be in the form of contact info. And finally, I will just go ahead and display the response, like how we display the result itself, right? So with the help of data class also, you can actually do the same thing. Okay. Now this is really important, and I hope you got a very good understanding that how you can actually work with data class, you got work with structured output, you work with Typedict, you work with Pydantic, and here in the data class we have discussed about all the three examples, right, from Typedict to data classes and all. So yeah, I hope you have understood this particular section. Now, the next section that we will be discussing about is like streaming. We'll be discussing about, sorry, we have discussed about streaming. We'll be discussing about short-term memory and other things, right? So let's continue the discussion. So guys, now we are going to discuss about middleware. Now, this specific topic is a very meaningful topic that has been included in Langchain, and it has some amazing functionalities. What we'll do in this section is that we'll talk about middleware, how you can implement with middleware by different inbuilt functionalities that are available in Langchain. We'll take some good use cases in making you understand. So first of all, we'll try to understand the definition. Okay. So let's say over here the definition is written. Middleware provides a way to more tightly control what happens inside the agent. Middleware is useful for the following. It tracks agent behavior with logging, analytics, and debugging, transforming prompts, tool selection, output formatting, adding retries, fallbacks, early termination logic, apply rate limits, guardrail, and PII detection. Now, just by seeing this definition, I know many of you will be specifically confused. So it is always better that I try to show you with a very good example. Okay. So let's consider one example over here. Let's consider an example wherein we take something like airport security. Okay. So I hope everybody may have been to airports. Okay. So in the airport security, if you go ahead and see that, right? So in the airport security, when you enter the airport, right? When you enter the airport, let's say you are the passenger. So let's say if this is your boarding gate or this is your flight, right? The boarding gate is somewhere on 18 number, right? Now to go to this boarding gate, you have to, when you're entering the airport, you have to cross through various stages, right? So you need to cross through security check. So let's say there is a security check over here. Then after crossing the security check, you may have to probably go to the immigration. After going through the immigration, you need to go ahead and board the flights. And then finally, you go to this particular gate number where you catch your flight, right? Now, in every of this step in the security check, what happens? We go ahead and apply, or over here, what will happen in the security check? They will probably go ahead and see your luggage, what is there in the luggage and all. Like you should not be carrying any batteries. That kind of check will happen. So this, I can basically say this as my middleware one. Okay, so I'm going to probably go ahead and implement one middleware over here. Okay, let me write it much more properly so that you should be able to understand, right? So here, what I can do, I can go ahead and develop my middleware one over here. And this middleware one functionality is that it will go ahead and do all the necessary check that is required, so that with respect to luggage, with respect to other things. Now, the second thing over here in the immigration counter, right? In the immigration counter, what immigration people will do, basically, they check your passport, whether your passport valid date is there or not, each and everything. So that kind of checks can basically happen in my middleware too, right? And before boarding, you know, here we will probably go, the people will go ahead and see your boarding pass, right? And see whether the boarding pass is right or not. So here we can go ahead and develop our middleware 3. Now, just by seeing this example, before any important, let's consider that this is my agent 1, this is my agent 2, this is my agent 3. Before the agents, we are doing something. It can be a normal check, it can be logging, it can be exceptional handling, it can be model calling, right? It can be anything as such. So that's the reason we have given this specific definition. Here, let's say it provides a way to tightly control what happens inside the agent. Now here we are considering this as the agent, and within this particular agent we can do multiple things, right? We can create middleware 1, middleware 2, middleware 3, right? And here we can track agent behavior with logging analytics, debugging, transforming prompts, tool selections. We can do multiple things in short of or different kind of functionalities over here, right? So this is what it is. See, this can be considered as a very good example. So before we have, let's consider this is my agent. Inside this agent, I have my model, I have my tools, okay? And this is nothing but this is a React agent, right? So model will, once we make a request to the model will see whether that request needs to be passed to the tool. Then the tool will execute it, give the context back, and finally we get the result, right? With the help of middleware, now my agent will look something like this. So agent with middleware. So in agent with middleware, here we will be able to see that there will be different triggers. Okay. So clearly you can see over here what is the best thing that is available. This middleware, right? It exposes hooks. We basically say it as hooks. Okay. Hooks means what? Hooks means trigger points. Before the agent, we can add something. Before the model, we can add something. This tools calls, you can see you can add something. After the model call, we can add something. After the agent, we can add something. It can be logging, it can be summarization, it can be multiple things in short. So here, in short, we are adding some kind of hooks. Okay. And we are adding these hooks so that we can do something over here. Right. Now, the best way is that we will see, first of all, some built-in middlewares. Okay. That is available. So we'll see some built-in middlewares. One of the middleware which is very commonly used is something called as summarization middleware. Now this summarization middleware is a kind of a middleware that we can use in the agent, and its task is only to summarize. So let's say if this is my LLM model or this is my agent, this is my agent, and let's say this agent is basically connected to a tool. Okay. And this tool is return connected, and here we get the output. Now here you can see that what this summarization will do. Okay. What this summarization will be specifically doing is that we add this middleware over here. We add this summarization middleware over here. So whenever we give any input and once we generate the output, let's say after some number of messages, after some number of input and output messages, you know that this messages list will keep on growing. So if I apply this summarization middleware, what it is going to do, it is just going to summarize this entire list of messages after it reaches some number. Let's say after it reaches some count. After 10 messages, I want this to summarize, right? All these 10 messages I want to summarize. Then what we can do, we can apply the summarization middleware within the agent, and its task will be that once it reaches 10, once the count of the message reaches 10, we are just going to quickly summarize the message, and this summarization of the message will be taken care by the LLM, right? So this kind of middleware we can add it over here. Okay. Similarly, there are other middleware. One of the middleware example is human in the loop feedback. I can basically say human in the feedback. So this summarization also, this middleware also I can add. There is a model tool calling. There is one more very good built-in middleware, and there are list of middlewares which can basically use it, like model call limit. Okay, model call limit basically means what limit the number of models to prevent excessive cost. So there are many. Okay, I'll just show you the I'll just show you the documentation. So here you can see I have summarization middle, where it automatically summarizes conversation history when approaching token limits. Human in the loop, it says. Pause the execution for human approval of tool calls. Then you have model call limits. Limit the number of model calls to prevent excessive cost. Then you have tool call limit. Control tool execution by limiting call counts. You have model fallback, to-do list, LLM tool selector, tool retry. So many different options are there. Okay. So I will now go ahead and show you that how you can go ahead and apply this middlewares itself, right? So first of all, what I will do, I will go ahead and quickly open my Jupyter notebook. So this is my some middleware over here. You can see. I will close this. Okay, this is my middleware code. So first of all, we go ahead and import, or we go ahead and load our environment variable with OpenAI API key. Okay. Now the next step is that we will go ahead and write our code. Now writing our code is very simple over here. Okay. Here, first of all, we will go ahead with our summarization middleware. Okay. Summarization middleware. Again, it is not possible to cover all the different types of middleware that is available over here, but I'll try my level best to cover some very important so that you can independently do all the things, after seeing some examples. Okay. Because at the end of the day, it's up to you for what kind of use cases you are specifically using this. Okay. So let's go ahead with the summarization. Now, summarization middleware, I will also go ahead and probably provide you some definition over here. Okay. So here you can see it automatically summarizes. So let me see. I will try to provide you a material which will be very meaningful and you should be able to read it later on. So summarization middleware is nothing but it automatically summarizes conversation history when approaching token limits, preserving recent messages while compressing the older context. Okay. So what it does is that it compresses the older context and it just use the recent messages whenever the token limit is reached. Summarization is useful for the following: long running conversation. So specifically in a chatbot, when you have a long running conversation, it is always good that we try to summarize the previous context. Multi-turn dialogues with extensive history application while preserving full conversation context matters. Okay. So now let me quickly go ahead and show you one example that how you can go ahead and implement this. Okay. So first of all, what I'll do, and we can use different triggers also. Okay, I will show you in summarization. There are multiple triggers which you can actually use. There is a token trigger, there is messages trigger and all. Okay, so first of all, what I will do, I will go ahead and show you how we can go ahead and create an agent. So from Langchain dot agents, I'm going to go ahead and import create underscore agent. Okay, so this is the first one. Then from Langchain dot agents dot middleware, I'm going to go ahead and import summarization middleware. Okay, then from Langchain dot we also going to go ahead and use checkpoint. Okay, the checkpoint is required so that I go ahead and apply some memory also. So I will go ahead and say memory. Okay, from Langchain dot checkpoint dot memory, import in memory. So I'm going to also go ahead and apply in memory so that I can go ahead and apply checkpoints within my chatbots, right? And then from Langchain underscore core dot messages, I'm going to use human message, and then I'm also going to use system message. Okay, so these are the basic libraries that I'm going to use. The first example that we are going to do is that message based summarization. Okay, message based summarization. So I'll go ahead and create my agent. My agent is equal to create agent, and besides this create agent, first of all, I'll go ahead and use my model. Let's say the model that I use is GPT-4o mini. Okay, 4o mini. So this is the model that we are going to use. Tools, you can go ahead and define your tools, but right now I did not define any tools as such. So I'm just going to go ahead and keep like this. Then we are going to use checkpointer. This is for my checkpointing, the whatever conversation history is there, I'm trying to save it within my local hardware, like in my hard disk itself. Okay. Now, to give the middleware as an option inside this agent, see, our main aim is that I want to add a middleware inside this agent, right? So here you can see I've given model information, I've given checkpointer. So here you can also go ahead and give your summarization, middleware as a parameter. So inside this middleware, you can give a list of middleware, like what all middlewares you really want to apply. So now here we are applying this summarization middleware within our agent. So inside this particular agent, we are applying summarization. But when do the summarization actually happen, right? That is the major question, right? So inside the summarization, we have an option to give multiple parameters. First of all, what LLM model we are going to use in order to do the summarization. So let's say I want to go ahead, and it's always a better idea that we use models that cost less for the summarization, because whenever the message expands up to a certain count, we are again going to do the summarization in short, right? So it is always good that you try to use a model, LLM model, which has lesser cost, with respect to tokens. Then I want this summarization to trigger, right? So there will be another parameter which is called as trigger. And inside this trigger, what we are going to do, we are going to put our condition, like when I want this summarization to happen. So here I will say when my message's length is becoming 10 at least, okay? My input, output, all the messages that is which is getting generated, whenever it becomes 10, usually whenever you create a chatbot, this number is a bigger number, right? But just to show you in this use case, we are going to set it as 10. Okay. Then I'm also going to say that at this point, you go ahead and trigger it. But when you trigger it, you summarize the previous context and keep the recent top 4 messages. Okay. Recent top 4 messages like that, right? So that we get the context and we go ahead and apply it. So here, what you can do, this is just one of the summarization which I have actually applied. Now you can keep on adding any number of summarization, any number of middlewares, right? You just need to put comma over here. Then you go ahead and define your next next middleware after this, right? Any number of middlewares you can actually go ahead and add it. Okay. So now this is a basic agent that I've actually created, wherein I have added a middleware of summarization middleware. Okay. So now once I execute this cell, my agent is ready. Okay. Now all I have to do is that in order to test this out, right, whether this summarization is happening or not, let's check it out how we can actually do it. Okay. So first of all, before I invoke anything with this particular agent, I want to go ahead and create a thread. Okay. So I will go ahead and run with a thread ID. And for this, I will go ahead and create my config. Inside my config, I'm going to go ahead and create my variable called as configurable. Okay. And then I'm going to go ahead and create my thread ID. This will actually uniquely identify a user. Okay. So here I will say test1. So this is my unique user. Let's say this particular thread is my unique user. And I'm going to go ahead and do this. Okay. Now let's create some kind of test data. Okay. So let's say these are my conversations. These are my human questions. I need to ask the agent, to this particular agent. Like what is 2 plus 2? What is 10 multiplied by 5? What is 10? The 100 divided by 4? What is 15 minus 7? And then my LLM will also keep on, my agent will keep on generating the answer. So here what I will do, I will say for Q in questions. Okay. And I will go ahead and generate my response. My response will be using this agent.invoke. agent.invoke, and here we are going to go ahead and set this in the form of a messages, because we need to provide in the form of a message. And here I'm going to go ahead and use my human message. My human message is nothing but whatever questions I have, which I'm reading in this Q variable, I will be giving it over here, right? And then I will have my config variable. Clear? Then what I'm going to do, I'm going to print whatever response I'm actually going to get. And along with that, I'm also going to print the length of the response messages. Okay. The reason why I'm printing the length of the response messages to show you, because here we have set up that whenever the message size increases more than 10, the summarization should happen. And when the summarization happens, this message length will get reduced. Okay. So here you can see I'm testing all these messages. So first of all, first question will go, what is 2 plus 2? And my LLM, my agent will provide me the answer. 2 plus 2 is 4. Then we are going to print that entire response. And then we are also going to see the length of the message response. Okay. And when this length of the message response increases more than 10, automatically the summarization will happen with this particular LLM model. So let's go ahead and try this out. Okay. So here you can see message, message 2, message 4, message 6, message 8, 10. Now automatically my summarization should happen over here. See, now it has gone message 6. And here is the content. Here is the summary of the conversation to date. Human asked several arithmetic questions. What is 2 plus 2? AI responded 2 plus 2 equals 4. What is 10 multiplied by 5? 10 multiplied by 5 equals 50. So here the summarization has happened Why it has happened over here? Because when my message length got triggered to 10, right? Triggered to 10, then it is going to go ahead and do the entire summarization. And that's the very important property of middleware, right? I hope you are able to understand the power of middleware, right? Let's see one more example. See, one of the trigger is through this way, right? Where we have, what we have done is that here I've applied this trigger based on the message length, right? 10. Now there is also different way. One of the way is basically based on token size, right? So let's go ahead and do based on token size. This was based on the length of the message. Now based on token size also you can actually do it. Now let's go ahead and do it. Now here what I'm actually going to do, I will first of all import all the libraries. So these are all my libraries that I'm actually going to import. From langchain.agents, import create agent. Then from langchain.agents.middleware, import summarization middleware. Then we are also going to create tools. Over here we have used human message in memory. And then this is the tool that we have created. Let's say that this is my search hotel functionality. And here I have hard coded some things. Okay. Hotels in this, and these are all the possible hotels that are available. Let's consider that this is probably returned from some API. Okay. Now what I will do, I will go ahead and create my agent, and this time my trigger will be token count. Okay. Token count. So token count basically means how many tokens is being generated by the model, right? So here I'm again going to use agent, create agent. Okay. And then we are going to go ahead and use model is equal to GPT 4o mini. Okay. And then I'm going to go ahead and use my tools. My tools will be nothing but, let's consider that I'm going to use search hotels over here. My check pointer. Let's see whether I've imported check pointer or not. Check pointer is over here, is equal to in memory saver. And then I'm going to go ahead and apply my middleware again. And this time the middleware that I'm going to apply is nothing but summarization middleware. And here I'm going to give my parameters. Let's say the first parameter is my model, which is nothing but GPT 4o mini. This time my trigger will be not based on messages, but based on tokens. So now I'm going to specify tokens, and token length I'll keep it to 550. Let's say that if it increases more than 550, then what I'm actually going to do, the summarization will happen. And when the summarization is basically happening, we are going to go ahead and keep the recent 200 tokens. Okay, so recent 200 tokens. These are the parameters that is available out there, right? And inbuilt parameters, right? So this is done. This is my summarization that is basically going to get applied. Let's see, did I miss out anything over here? This should be trigger is equal to, okay, perfect. Now this is my agent that has got created. Now what I will do, I will go ahead and create my config. Okay, so config will be nothing but this config, so that we apply for a specific user. And just to display or print how many tokens has been generated, I will create this function called as count tokens. Total character is equal to some length of whatever content is there, right? That length. And we are saying that we are considering, okay, 4 characters is equal to 1 token. Okay, 4 characters is equal to 1 token. So this is what is basically happening. Okay. So now I'm getting an error. Let's see, unable to find GPT 40. I've written 40. It should be 4o mini. 4o mini. It's okay. Please specify model directly. Okay, GTP. I have written it over here. It should be GPT. GPT. Okay. Now done. This is done. Okay. Now we are going to go ahead and run it. Okay. And we are going to run this test for the. So here you can see I have created cities like Paris, London, Tokyo, New York, Dubai, and Singapore. And this is my question. Find hotels in this specific city, right? And we are doing agent.invoke. Then we are counting the total number of tokens from this response.message, and I'm printing both these things. Now here you can see one very important thing is that when the token size increases 550, more than 550, then the summarization will happen, right? So now let's go ahead and execute this. This is good. Okay, you will be able to see the response. So here 149 tokens is there, 4 messages. Okay, now this will increase 302, then 456, Then when it increases to 550, so see, now from 456 it has become 396. That basically means over here after this 550 had expanded, so we are able to do the summarization. So after 396 again it went to 232. That basically means summarization has happened here also. See, here is a summary, here is a summary, and here also summary, right? So the summary is basically happening over here, right? And based on this you are basically getting the response. Okay, including the grand hotels, all this information is there. So summarization is specifically happening once your 550 tokens is getting over. Okay, now this is one more way, and one more way I want to go ahead with, which is basically called as based on fraction. Okay, now what is based on fraction, how based on fraction it is going to apply. Okay, here this time I'll copy and paste some code, and you can just go ahead and see it to it. Okay, so here you can see I have my search hotels. This time the trigger will be based on fraction, not on token. And fraction I have given 0.005. 0.005, this fraction is based on the context of the LLM model, right? So if the LLM model is able to accommodate 160k tokens, right? If I give the fraction as 0.005, that basically means zero point 0.5 of 6 of that many number of tokens is equal to 640 tokens. That is what I've given as an example. Okay, we can also convert that. So it is based on different LLM context size. Here we are going to use fraction. Okay, so fraction is 0.005. That basically means 0.5%. 0.002, that is nothing but 0.2%. And here again you can see I'm counting the count tokens. Everything is same. And here we are using config. And here you can also go ahead and see the fraction. So whenever this fraction increases 0.005, then we are good to go. See 0.9. Here 133 tokens, 0.15, 0.21. Whenever it reaches 0.5, okay, 0.5%. You can see if it does not reaches 0.5, that basically means summarization. So here it has increased. So here you can see summary of the conversation. It has increased from here to, and what we have done is that here the summary has been created, right? So that basically means the percentage of the token has got, the fraction has got increased, right? So this was just about summarization, and three types we have learned. One is based on token size, one is based on the number of messages and all, right? And an amazing summarization technique. And if you go ahead and see, this is the summarization over here. You can see some examples, but I have probably given you a very good example. And there are also other built-in middleware. Now you can use any of them, like tool call limit. You know how to apply it. So inside the middleware, you go ahead and apply it like this, right? And let's say you want to probably go ahead and apply model fallback, right? So model fallback basically means from one model, if some model is not there, you can fall back to the other model, right? Let's say if this API cost or API key is not working, then it will fall back to the other model, right? So what I will show you is that in the next section, I will show you how you can also go ahead and apply human in the loop. A very good example, because human feedback is always required, right? Whenever a task is basically happening in the agent. And that is what we are basically going to go ahead and discuss. But I hope you got a clear idea about summarization middleware. So now we are going to continue a discussion with respect to middleware, and we are going to discuss one more type, which is called as human in the loop. Okay, and this is a very important functionality in terms of middleware. So here, what this does is that it pauses agent execution for human approval, editing, or rejection of a tool call before they execute. Human in the loop is useful for the following. High stakes operation require human approval like database writes, financial transaction, compliance workflows where human oversight is mandatory, long running conversation where human feedback guides the agent. Okay. Now let me just open my Scribble notebook and let me talk more about it. Let's say that I have a specific agent and why human in the loop is actually required. Let's say this agent does some kind of task. Okay. And whenever we talk about agent, these are basically autonomous agent. Okay, autonomous agent. When we say autonomous agent, that basically means without much human intervention, it will be able to do some specific task. Let's say this agent actually does a work, and it is a critical work. Let's say with respect to financial transaction. Okay, financial transaction. Now, when I say financial transaction, let's say this agent helps me to buy stocks. Okay. Now, let's say, and see, this is definitely a very critical task. I hope you agree with this. This is a critical task. We cannot just directly, we cannot, completely be dependent on the agent to do this specific task. Some kind of human intervention is definitely required. Let's say for the next day, the agent is going to probably go ahead and buy a stock, and automatically goes and does some kind of mistake. So there may be a huge loss of finance in this side. So we cannot be completely dependent on the autonomous agent. What we can actually do is that we can add a human over here, right? And we can make sure that whenever an agent takes any decision in this kind of critical task, first of all, it will go ahead and request this human to provide a confirmation, right? And that is the reason we say human in the loop, right? We are always asking feedbacks to the human being, because at the end of the day, unless until this feedback is not given to the agent, this kind of task will not get completed, right? And this is really important, because for any kind of critical task, we need to have human intervention, because there may be mistakes that an agent can make, that an LLM can specifically make, right? So now we are going to understand how we can actually go ahead and implement this kind of middleware. Okay. So here you can see I'm actually working in the same notebook. Okay. What I will do is that I will go ahead and import some of the libraries. The first library is that with respect to create agent. The second library I'm going to import is from langchain.agents.middleware, import human in the loop middleware. Before we are just using summarization middleware, right? Then we are using checkpoint.memory in memory, right? Now let's say that I want to do a specific task which needs to be done, or which needs to be intervened by the human being again and again. Basically, my agent should go ahead and ask continuous feedback, with respect to any task that it does, right? Now, what I will do, I will go ahead and create two important functions. Let's say one of my agent work is basically to send emails. Okay. So here you can see that I have two different functionalities. One is read email. Here we give the email ID. Email content for ID. This one is there where we are reading the email. Then second is send email tool. Okay. So this basically sends the email, right? Here I know I've just written some kind of dummy information saying that email sent to recipient with subject this subject. Okay. This is what is my basic thing over here. Again, if you really want to implement a end-to-end email thing, you need to use a SMTP server, and based on that, you can actually do it. But the core idea over here is that I just want to show you to do this particular task, I want my agent to be always intervened by human beings. Okay. So these are the two functionalities that I have, like kind of a tool. Now what I will do, I will go ahead and create my agent. My agent will be nothing but create agent. Here, the first thing that I'm going to use is model. So model, I'll write GPT-4o. Okay. The second parameter that I'm actually going to use is tools. Tools, here I'm going to go ahead and provide my tool called as read email tool, send email tool, whatever tools I have written over here on the top, because my agent work is basically to send a email, right? Then here I'm going to use a checkpointer. This is for my memory. So in memory saver, in memory saver, I'll go ahead and initialize this. Now I'm going to go ahead and add my middleware. Okay. Middleware. As I said, you can also add summarization middleware over here. But this example, I want to show human in the loop middleware. And inside this human in the loop middleware, I will have multiple options. One is interrupt. So I can go ahead and use interrupt. So I will go ahead and use something called as interrupt underscore on. Okay. Is equal to. Now where I need to interrupt, right? That is what we really need to understand. Where we need to interrupt it, on what kind of action I want to interrupt it. And now in this particular scenario, if my agent is sending a mail, I really want to make a confirmation from the human being, or get an approval from the human being before sending the mail, right? So here what I'll do, interrupt on, I will write, okay, this functionality, which is called as send email tool. So whenever this functionality or this tool is basically getting called, I need to go ahead and ask for the human permission, right? Whether we should allow it or not. So here I will say allowed underscore decision, which you can hard code it. Okay. Decision. And here I will say, I will have three important things. Okay. Three important things. One is approved. edit, or reject. Okay, so I'm saying that there are three important options that you can basically interrupt on, and human can basically approve it, or edit it, or reject it. Okay, either it can approve, okay, go ahead and send the mail. Either it can say, no, no, don't send the mail to this email ID, to some other email ID, that is reject, edit. And third one is something called as reject. Okay, so this on send email tool, I definitely want uh, I definitely want a kind of interrupt, right? Now, with respect to read email tool, I don't want anything. So what I will do for this particular tool, I will go ahead and say, hey, go ahead and make it false. So whenever I'm making this particular tool call, for this particular tool call, I definitely need to go ahead and take an approval from the human being. The human being can provide three options. One is approve, edit, and reject. Okay. So this is done. Very clear. So I will go ahead and execute and create my agent. Now, once I have my specific agent over here, now the next step is that what I will do, I will just go ahead and create a config file. See, config over here, I'll say test approve. Let's go ahead and do the test approve with this thread ID. Thread ID indicates unique ID. Okay. I'm using message.invoke, messages, human message, and I said send email to john@test.com with subject hello and body how are you. Okay, so this is my input that is given over here. Now, once I give this particular input, the agent will know, okay, it has two tools. One is read email tool and one is send email tool. So it will first of all go ahead and execute read email tool. Read email tool is nothing but it goes and read the email by its ID, and send email is nothing but it mocks function to send an email. Okay. Now, while reading this particular read email tool, it will not do anything. But once it goes to send email tool, it is going to create an interrupt. Okay. So let's see this. So I'll go ahead and execute it. And now I will go ahead and see my result. See, there is something called as interrupt. Now, why interrupt is basically happening over here? It is very much clear because we have created a trigger over here, right? In this particular in this particular middleware, wherein wherever the send email tool is basically executed, we need to go ahead and take a permission from the human being. Now, what is basically happening for this send email tool? Now we need to take a approval from the human being. Now, for the approval process, it is very simple. I will go ahead and write this particular condition. Now, see this. I will write if __ interrupt is present in result, print pause approving. Then I will say agent.invoke. Now see, human needs to give the confirmation. Okay, go ahead and send the mail, right? Then how that execution will basically happen, for that we use this particular library which is called as command. Okay. Now this command, what it does is that it executes a command. Okay. Now, what command it basically executes? It executes, says that, hey, execute the workflow, resume the workflow, and there the decision type will be approve. Now, this approve, if you remember, it matches this, right? So, we are saying approve, right? So, here we are saying approve, right? And for the same config, then we will be able to see that the mail will be sent. So, this is the code wherein the human is approving, right? If you, instead of approve, if you write reject over here, it will get rejected. Right, so this is the human approval that is basically happening. So once I execute this, I'm getting an error saying the command. Okay, command is not there. We need to probably go ahead and import the library which is basically called as command. Okay, now command libraries will be available. Let me just open my browser, and here I will search for Langchain command. Okay, so Langchain command. Let's see, there is interrupts. So interrupt command resume. So here you can see from langgraph.types import command. So I'll go over here. I will paste it here itself. Okay. So here you can see that I'm basically pasting it over here. I'll execute it. Now this should basically execute it. Now here you can see the email has been sent to john@test.com with subject hello. So before my result was this. Now, if I go ahead and see my result, it will basically have the tool message, which is nothing but email sent to this, because this is the tool that is basically getting called, right? The send email tool. This tool is basically getting called. And that has executed, wherein it has said that, okay, we have sent an email to this. And finally, the AI message is saying that the email has been sent to John Test with subject hello. Okay. Now, similarly, let's say you want to do it for reject. Okay, so how do I do it for reject? Let's say the human wants to reject this. Okay, it does not want to continue with this, right? So for reject, again, I will use the same code. Let's say this is my agent, entire thing. Okay, I will execute this. I'll open more code cell. Now I will go ahead and set my config. Now here we are basically saying that, okay, fine. Agent.invoke. Okay, I have to basically close the brackets. Okay, now I'm using this test dash reject for this particular thread. I'm using this unique. And then for rejecting, I will just go ahead and update my code. Instead of making that decision type as approve, I'm going to use this as reject. So this reject and this reject are matching, right? And then I will just go ahead and execute it. Pause approving. You can see it seems that was an issue with sending an email. Now, if you go ahead and see the result, you'll be able to see that user rejected the tool call, right? Very simple. Here we are using this command. Okay, this command is really, really important. It's just to execute something in the specific workflow, right? And finally, you can also do it for editing, right? Let's say that I don't want to drop a mail by mistakenly I have given some other email ID. I want to change the email ID, right? So everything is same over here with respect to creating an agent. I will go to the next step. I will go ahead and create my config. Let's say I go ahead and send an email to wrong@email.com with subject text and body hello. If I go ahead and execute this, I will go ahead and show you the result. It will be interrupted, waiting for the human feedback. Now the human can basically say, hey, go ahead and execute the type edit. So here you can see if interrupt in result, agent.invoke command resume is equal to decision type edit and edited action. We have said that, okay, name send email to, we are changing the argument, recipient, subject, and body. Okay. So this was edited by human before sending. And I'm giving the same config. If I go ahead and execute this, you should be able to see what is the output that will be. The email has been sent successfully. Now, if you go ahead and see the result, you'll be able to see that the email sent to correct@gmail.com, right? So here we have edited it, right? So for edit, you have something called as edit action. So this is basically with respect to the human in the loop middleware, which you can go ahead and try it and do it from your side based on your requirement. Okay. Now the next thing is that you can still go ahead and explore all the other built-in middlewares like model call limit. Let's say you want to have the limit the number of model calls to prevent infinite loops. You can go ahead and use this thread limit, run limit. You can go ahead and see what are the configuration options. So this entire page, you can go ahead and explore it by yourself. And you can do multiple things. You can do LLM tool selector option is also there, right? So here you can see tool selector middleware. You can see agent with tools where most aren't relevant per query, reducing token usage by filtering. So for different tasks, you definitely have these amazing middlewares, okay, which you can actually use. So I hope you have understood about middlewares.